And today we are going to cover, first off, just what is cold bonding, the working principle and function. Then we're going to go into how we design these repairs and going through how to install them. And then finally, we'll end with some case histories. So hopefully this is beneficial to you guys. And if you have any questions, you can put them in the chat. And at the end, we'll do a little Q&A for any further questions. So starting off, cold bonding, an alternative that you can think about is this is kind of like a fillet welded patch or a reinforcement sleeve for piping. But instead of welding, you are going to adhere the plate or the equipment with the Belzona adhesive. So some of the applications, as you can see here, we have a tank that had some leaks, and we bonded plates over the leaks to reinforce it and add pressure retention in those areas. On the bottom right, we have a flange that needed to be installed over a hatch on a ship. They could not do welding at the time, so they bonded it in place with Belzona. So the cold bonding comes from no hot work required. This can be done, on live equipment. It can be done in tight fit areas, and you can have custom fit equipment, custom, bonded onto your equipment. So going into why you would use a cold bonding repair. So one could be a load bearing. So this case right here on the right, they needed to install a fire water sprinkler system around this tank. The tank was in service, so they could not do any welding. They could not do any hot work, but they needed brackets to hold up the piping. We used our cold bonding solution to adhere these brackets, and we calculated how big the bonding area needed to be to hold up these brackets, and we'll go into how you would calculate that later. But this was done with vapor blasting and cold bonding, which does not require a hot work permit. So in the end, they were able to carry the piping. Another area where you want to use it is adding strength or stiffness to your metal. You might have some metal that's severely corroded, thin wall, and it's lost some of its strength. So you can bond another plate on top, and then their strength can kind of accumulate with another plate. So, take some of the stress off of your plate, that your metal that's been deteriorated. Fluid containment, this is a very typical application. So anytime you have a leak in a pipe or a tank, a lot of times you can cold bond. Sometimes we can actually do it with a live leak with a special leak sealing method that we have. In another case, if you're down for a little bit, we can bond a plate and have a quick curing material where you can start back up as soon as possible. So definitely bonding over leaks is one of our bigger application fields. And then erosion and wear resistance. So sometimes you might have an area that's being eroded. It might be a vessel that has a inlet coming in and hitting the wall, really eroding that one area pretty bad. So you can install and bond in a wear plate that's going to be designed to protect that vessel wall. This is used a lot in mining and chutes where it's just getting beat up in a certain area, and you can bond in a wear plate instead of welding one in or putting exotic metal or something like that. So how do we know that it's going to work, and how do we guarantee a long-term protection and long-term application? So first, you got to start out with your excellent adhesion. You guys know Belzona. It doesn't really come off. You get it on your clothes, forget about it. So it has some of the best adhesion in the business. We test our adhesion in different planes, because whenever you do a cold bond repair, you can have different loads exerted in different directions. For example, if I have a shear load, like that bracket example that I was talking about, I'm going to want to make sure my shear adhesion is great enough to overcome any load put on it in a shear direction. Same thing for kind of a leak. Whenever you bond a plate over a leak, that pressure from the pipe or the tank it's kind of putting a tensile load on the bond. So you want to make sure your tensile adhesion is going to be great enough to overcome that load. Sometimes you might have a cleavage adhesion. This is seen a lot. For some applications, we bond handrails down, and that would be more of a cleavage or moment adhesion. So we test that as well. And the basics, if you see these numbers, the testing that we do, the end outcome comes in a PSI format. So whatever your plate area is, if it's a 10 by 10 plate inch, you would get that area multiplied by your PSI of adhesion, and that's going to give you a pound's force that you can handle. So anytime you have a load and you say it needs to handle 200 pounds force, we're going to find a plate that can handle that load. And as you can see, these are pretty high, so most of the times you're going to have a lot more adhesion than you need. Secondly, you want to look into the mechanical properties. Make sure your tensile strength is going to be high enough for the application. Compressive strength is one that comes into play a lot because you might bond down a plate that's going to be in a compressive load. So you want to make sure that whatever adhesive you're using can handle that compressive load. So that's definitely something that we look into as well for every application. And finally, a pretty important aspect is going to be your corrosion resistance. For some of these applications, we actually bond like internal furniture inside of tanks or pressure vessels. So we're going to want to make sure that whatever adhesive we're using can handle the chemical that it's being exposed to. So we do chemical testing, ISO 2812-1. So we test a whole bunch of chemicals, and we have very organized chemical resistance charts that we can look up and make sure that whatever chemical we're going to be exposed to, we can handle. Salt spray cabinet is another corrosion test that we do. This is very, very good for anything near, offshores. It's pretty important. Anything near cooling tower, mist. This is a good test to understand if it can handle a corrosive atmosphere. And then finally, if you do have some cathodic protection nearby, it's really important to understand your dielectric strength. We also have cathodic disbondment testing. So this is all just to make sure when you install this, it's going to work in that environment. Of course, we can design it correctly, but the main thing, one of the most important things with any Belzona application is going to be the actual installment. So when it comes to procedures, first off, we'll provide training if you need some training on how to install these. And secondly, we do provide full scope procedures, step-by-step instructions with drawings. When it comes to cold plate bonding, there's typically just two kind of methods. For small plates, I would say less than 2 foot by 2 foot. We call it the manual method. So this is all hand applied. And I have a little video after this to show you how to do it. And then we have for larger plates, we have what we call the injection method. So we'll go through both of these methods, starting with the manual method, which is, your typical application. Normally the plates, for your typical application, this is going to change every time, but they're normally about 1 foot by foot, that kind of size range. So if you have a plate this size, the way you do it is firstly, you want to prepare the surface of the substrate and the underside of the plate. For you to get the optimum bond, you need to have that proper surface preparation, which is going to be, abrasive blasting is the best, but we can also do power tool cleaning and different forms of surface prep. Once you have your prep done, you're going to apply the Belzona adhesive to the bottom of the plate, and you apply it to the actual substrate where you're going to be bonding to. Then you're going to press them together as tight as you can. There should be some product coming out of the edges. That ensures that you don't have any air voids. With your finger, you can kind of chamfer the edge and make a nice bevel around the plate. And then you want to hold it in place until it's dry. That's a crucial component. So anything from ratchet straps to magnets to any other form, you just got to hold it in place while it cures. And then once it's cured, you can remove that, and your plate will do its job. Secondly, if you do have a larger plate, we've bond plates the size of doors. You're not really going to handle that by hand. It's not really practical. So like with every application, you start out with your surface prep. As you can hear, they got their surface prep and they're doing their inspection, their QA, QC, is taking some profile readings. And this will all be in the specification procedure, what kind of prep you need, what kind of anchor profile is required. It's in our instructions for use for each product, and we'll make a custom procedure if you have a specific application. So for the injection method, the first thing they do is they bond down the plate, they bond it down on the perimeter. So about a 4-inch wide band along the perimeter of the substrate and the plate, we apply our Belzona paste grade material. And as you can see here, they had to cut this plate in a specific way for it to fit. That's a typical thing when it comes to cold bonding is sometimes we go over nozzles, sometimes it's a weird location, maybe around a flange or a pump. So you might have to have a custom fit plate. So once you have the material put on the perimeter, you're going to bond it down in place and allow that perimeter to cure to a machinable or hard degree. Once the plate is in place, we have these injection ports all along the plate, and we're going to inject a fluid grade material. This right here is a airless single component pump, and we're pumping in Belzona 5811, which is one of our corrosion resistant epoxies, fluid grade, and that's going to fill in the entire void of the larger plate. Now there's a lot of advantages to filling up the whole plate. You're going to avoid any humidity in there, any corrosion that could happen, and you're also really increasing your adhesion by quite a bit. You can imagine with PSI adhesions in the 3,000 to 5,000 range and a plate this big, how much load you can carry, how hard it would be to take that plate off. So that plate is not going anywhere. And when you inject, you start in one injection port, and you'll see the product eventually come out all the other injection ports, and that's going to ensure that you don't have any air voids, there's no air pockets, and you have a full seal of the void area, which is crucial. So once you've sealed in the void, normally we come with some paste grade and kind of smooth out all the injection ports, smooth out the seams if we have to. You kind of butt them up as close as you can and kind of put a seal around the perimeter. And then you want to prep the outside and do a full deck coating if you have to. And typically in the field, we'll give it a corrosion coat to avoid any corrosion of that top plate, top side of the plate. So how do we, from start to finish, I mean, the first thing we always do is try to get a good understanding of the damage. So we do a damage assessment through an ASR, which is an application survey report. We have a lot of different consultants that can come out to the field, take a look at the issue, and work with you to understand what we are trying to do. What's the functional requirement of the repair? Are we just, reinforcing some steel that's severely corroded? Are we using it to hold up for a load-bearing application? Is it to contain a pressure leak? So once we really understand the repair, we can come up with a design, draw out what kind of plate geometry we need, what size of plate we need, make sure that the adhesive is going to be able to withstand the loads, withstand the chemicals involved, and we'll come out with a full specification and procedure. At that point, it's all about installation. So like I said, we do offer training where we can train your guys and we can make a simulation of the repair we're going to do. And we also have our in-house team that can provide turnkey work. Quality control during the application, I mean, it's crucial. That's why we do our training and certification. And we also have our in-house team that when you go out there, you need to make sure that everything is done as per the spec. And that's how you can ensure, that's how you get your quality assurance. So going into some examples, I usually like to start out with this one. It's kind of a wild example here. It's not your everyday application. So this was a 22-ton riveted storage tank that needed to be moved out of the facility. It needed to be moved to another spot in the facility. They could not do any welding, and they didn't want to, take it apart and move it that way. So we came up with a design that had enough load capacity where we could carry actually a 420-ton tank. So as you can see, we had plates here with brackets that were installed and cold bonded onto this tank, and we calculated with our shear adhesion numbers that we could hold up 420 tons. So quite a big safety factor. But we also wanted it to be even around the crane so it wasn't leaning anyway. So we bonded all around the perimeter of the tank, and a crane came in, attached to those cold bonded plates, and safely moved that tank where it needed to be. That's not your everyday application. If you do need to move a tank, just give us a call. But that just shows you the kind of strength of the bond that we have when done correctly. This is an application, so that would be considered kind of a load bearing, so it's going to carry some weight. This is more of a strength and stiffening application. and also corrosion resistance. So they had a offshore deck that was severely corroded, kind of thin walled in a lot of areas, didn't have the same rigidity it once had. So one option is to cut it all out and weld new plate, and they chose to go with this cold bonding method, which showed to be a little more efficient and also kind of saved their deck that they didn't have to replace it. But basically what we did was we bonded a whole new deck on top. So you're going to get the strength of the new plate and still conserve whatever strength and structure you had of the old plate. So this was the same example that I showed you earlier, injection method, because the plates were quite large, and then we coated on top to prevent any future corrosion on top. So this was installed in 2016, still in service and approved by ABS. So to this point, I've just been talking about bonding steel plates, but you can bond other types of materials as well. This is one application where we actually fabricated a plate out of our super wrap material, which is a carbon fiber composite. The benefit to this is one, it's fast, so we can start making this today instead of having to go to a machine shop and getting something cut, anything like that. We can fabricate this, on site or in-house here the day of. The big advantage is this is a lighter than a 1/4-inch steel, much lighter. So this was going on top of a roof, and the roof, they didn't want to add too much weight. You also have, this material has a very good corrosion and chemical resistance. So this tank contained methanol, and we needed something that was chemically resistant to what was inside the tank. So it had some vapors, methanol vapors. And then we bonded it down with an epoxy that is also resistant to what's inside the tank. So that's the key. You always got to understand, is there an issue with weight? What kind of chemicals are inside? The good thing about the super wrap as well is we can blast this offsite and it's not going to flash on us. So we prepped it offsite, came to the site, did what we had to, and just bonded them in place. So it can be a fairly quick application as well. This is another example similar to the deck example. This is right by an unloading area. So this deck was, obviously getting its normal offshore corrosion, but it also had a lot of, impact and abrasion and forklift traffic. So it gets beat up quite a bit, and there's a lot of loading on these plates. So we use that same injection method, and they've proved, 17 years in service, that bond is held up, even with all the impact and forklift traffic. And, you get, especially on those decks offshore, when you have that forklift going, you get a lot of moment and, bending and stuff like that, and the bond is held up just fine. Another, this is a typical application. This is a pressure vessel, had some, pretty bad external corrosion, even had a little through wall defect here. So, you have different ways you can attack this, but a cold bond is a fairly quick and easy way to upgrade your metal. So instead of, getting a new roof welded in or anything like that, we're gonna cut out some custom cut plates, bond them in. Now we basically have a new roof to this pressure vessel, new head. And as you can see, they were completely covered in paste grade. Next day came back, or same day at times, you can top coat it with something that's corrosion resistant, and that way you prevent any further corrosion. So you basically have a whole new head to this pressure vessel without having to take it out or bring anything cut or weld or anything like that. And then your typical application, get these calls all the time, I got a leak. Like I said, with leaks, we can do them live at times. We can also, obviously, can do them offline. It's just a little bit different. And if you're interested in leaks, we can do we've done webinars on that, and we're happy to do another one. But this was a live leak. We were able to plug it with a epoxy stick that we use to plug leaks. Once the leak was plugged, we quickly bonded a plate using our quick cure material. That way it's the fastest cure possible, and sometimes you need that, especially if at times people go down and they can only go down for a day. So we can come in and do a quick cold bond procedure we have materials that can cure in 2 hours. 2 hours later, they're ready for service. So offline, online, we have different ways that we can attack it. As you can see here, they use the wood 2x4 or 4x2 to hold it in place. I mean, at times we use ratchet straps, magnets, something to hold it in place and make sure that that bond cures properly. So that's a key to cold bonding. So like I said, these are short presentations just to give you kind of an overview